network is actually one of the leaders in the world.
I think the lights should be switched off, right?
Yes, sir. The presentation.
Yeah, the lights.
Right? So Silicon Labs is the leader in something called IoT wireless connectivity. You know, a lot of devices that you have around the home today are connected to your Wi-Fi router. It's not just your cell phone and your laptop, but it can be a refrigerator, it can be your washing machine, it can be TV, it can be a window blinds, it can be lights, it can be a door lock. Everything is now part of an entire network called IoT. It is there in the home, it's there everywhere. And all of these devices, most of these so we do multiple types of wireless. All of it. So in our company we have many areas of work. Chip design, we call it SoC design or system on chip design. CPU, memory, peripherals, everything put together in a chip. We also do analog and RF design. Those of you who study electronics will know about all the transistors and op-amps and mixers and RF circuits which you have learned maybe. We do signal processing because we receive wireless signals, we have to do processing to extract data from it. We have groups which does the back end of IC engineering, which is the actual conversion of circuits into a product. We have a lot of software engineers, but the software engineers are very close to hardware. That means that they need to understand how you can write embedded code. So we have protocols software, we have we also have product management, marketing, sales, and everything else here. So all areas that are needed for a company are here at Hyderabad also. Okay, so if you look at a generic view of a connected system, what do you mean by a connected system? A system that does not work just by itself. It works in conjunction with so many other devices. Everything is connected. When you take a car through a FASTag reader, okay, there you have a tag in your car. It goes to the reader. The reader transfers the information to a server. The server will check with your ID how much money you have. Then it deducts that money and then it opens the gate. Okay? The gate has got a system, it's got a motor, you got a tag, you got a reader, you got a server somewhere. All of those systems must be connected in order to make something work. So if you look at a generic view of a connected system, you have a microcontroller. It's always there in all systems today. Very difficult to get people to design something without microcontrollers. I've done a lot of things without microcontrollers, but today microcontrollers is so cheap that you can put everything. Whatever you want to do, you can put one there. You also have sensors because you need to find out what's going on. If you want to control something, you have to find out what the input is. And you also have the opposite of sensors, which are called the actuators. The motors or the switch for turning on the light and everything, they're all called actuators. Okay? And then you have a wireless connection. All this is part of a device. We sell it in a microcontroller. And then the information is going through a gateway. Gateway is like a router. To the cloud. The cloud, why do you call it a cloud? Cloud means we don't know. Somewhere server is there and the data reaches the server. On the server, you do a lot of analytics. All the data you collect, you have to decide you want to do this, you want to do that. Are those devices which are there physically that you can see? Devices are somewhere beyond the cloud. Physically, somewhere we don't know. But the network takes our data there. Now, AI requires a huge amount of processing. And most of that processing requires heavy-duty servers. They're all done in the Amazon. You have an AWS account, so you can do your training on AWS server or Microsoft Azure or Google. You can always do it outside.
I kept that battery on charging.
AI is also done at the edge. So let's look at what else, or it could be a door lock, which is opening that, which also includes gateway or the Wi-Fi router. So if you have 10 let us say, sensing temperature. All of them are connecting to a local server, which is also called a gateway. And then the gateway does local processing before sending it to the cloud. Gateway can also be part of what we call as the edge. There's another definition where they call the gateway as the edge and they call the device as the tiny edge. So you will see tiny ML, tiny edge. Okay, sometimes you will call the gateway as a fog computing, but in general, just imagine that the edge is a device and the cloud is what is on the servers. Okay. So with that definitions behind us, let's look at what is inside a device from a technical point of view. Now, we are all engineers. Whenever we get something, a true engineer will want to open it and see what is inside. We don't, if you buy something very expensive, we don't open it and see it. But the mind of an engineer is curiosity. How somebody built it? Can I also make it? So let's look at what's inside the device. The colors don't come out so well, but see, at least maybe I cannot, maybe you can see, is sensors and actuators. Then you have a microcontroller unit with peripherals. That means that you have interfaces like a interface, PI interface, I2C interface. Then you also have timers, interrupt controllers. They're all peripherals. And then you have an analog subsystem, a wireless subsystem, and an RF subsystem. Let's look at what's inside of these. Inside a sensor, commonly use sensors like inertial. Inertial used for inertial sensor means it detects movement, it detects whether the object is this way or that way. Your phone can turn off if you keep it upside down. We have accelerometers, measure acceleration in 3 different axes. See, if I'm standing here, I have X, Y, and Z. Now in Y-axis, which is vertical, I am experiencing acceleration due to gravity. So a 3-axis accelerometer 9.8 meters per second square in axis. Z right now it should show 0. If I'm standing still, it will show something. So a lot of movement-based sensing is done in inertial sensors. Then you have the usual temperature, humidity sensors, infrared sensors, very often used in if you have a CCTV camera, you are uploading data all the time. You have an IR sensor. If somebody comes near, then you turn on the camera. Nobody is there, no point in turning on, right? So you can have sensors there, lighting control of a home. You can imagine there's gas sensors are there, so many different, hundreds of types. Now what's inside the microcontroller? Most important thing is of course the CPU or the processor. The embedded processor can be you can build an SoC using RISC-V. As a student, you can do a project for yourself in your disk. You pull the microcontroller RISC-V core, you add your own design for a peripheral, and then you can build an SoC yourself. Okay? It's not at all difficult, you can all do it. So anyway, the CPU can be one of those. You need SRAM. SRAM is the fast memory in which, okay, suppose you have a declared variable called array of. The array takes up some space. That space is allocated. If you don't have RAM, your malloc function will not return, true. You won't get space allocated. So SRAM is important for all the scratch data and all the data processing, all your variables you use in your code. For all of that, you need SRAM. And then you have flash. What is flash? SRAM means if you turn it off, all the data is vanished. What is flash memory? Even if you power it off, data is still there. So flash is where you store your code. Your code doesn't change. Next time you power on, it will start from location 0 again in the flash. And then as the program runs, it will request for memory, it will use SRAM, it will collect data from a sensor, store it in SRAM, and all those things. So very important. The CPU, SRAM and flash are very important. Then you have other peripherals like interfaces like I2S is used for audio processing, for your headset. You can use I2C for a lot of sensor interfaces. You have timers. What's a timer used for? Most devices are asleep 99% of the time. Your phone right now, if you're not talking or watching a video, is asleep mode. Every so often it wakes up and checks whether I should do something. It can be woken up by interrupt, like you press a button, or you pick it up, or an incoming call comes, it can wake up. It can also wake up periodically, and for waking up periodically, you need the timers. Okay, then you have general purpose IOs, you sometimes have DCs and DACs, so you can actually interface to analog world and get analog data out again. So all of these are part of the SoC and generally called the peripherals. Okay, there's also one interesting thing called WDT. Does anyone know what WDT is? Okay, it's called a watchdog timer. And does anyone know what's the purpose of the watchdog? Anyone? We have some nice prizes to give away for those to answer questions. I don't know what they are, but we'll give you something. Alright, the watchdog timer is sometimes a program gets stuck. You can always write a program that gets stuck. You may do it intentionally, you may do it unintentionally also. So a watchdog timer is a timer that keeps running. In your program, every so often, you should go and reset the timer. Because if the timer reaches a maximum or certain limit, that means that your program is stuck in a loop so that you are not able to reset the timer. That means your system is stuck. And if your system is placed, if your laptop is stuck, you can reboot it. If your phone is stuck, you can reboot it. But if there is a system lying on that corner, you can't climb up and reboot it. So the watchdog timer, if it reaches a limit and the program is not resetting it, it will issue a hard reset to the whole device. So the device will restart automatically. So it's so important that if you don't have it, okay, most devices will get it. Alright, so this is a battery management. So it has to do a voltage also a Bluetooth headset. We want to see somewhere how much battery is still left. You don't want it to suddenly die. So brownout detection, that means it's becoming not black but brown. Okay, from white it's becoming brown, then it will become black. If it will become black, that means there's no energy. When it's brown itself, you have detected. Okay, then you have a real-time clock. And then you have the wireless communication system, which is signal processing for transmitting the data using an antenna. Use RF frequencies. Wi-Fi uses 2.4 gigahertz and 5 gigahertz. Cellular uses 700, 800, 2100, 2300. So many bands are there where cellular is used, which is a transmitter and receiver, up converter. You multiply it with your baseband data. You get the data modulated onto a carrier, and then you can amplify it and send it out on an antenna. So all of this is usually present in a small chip, and which that is present in any wireless device. It can be a Bluetooth headset, it can be a smart lock, it can be a fridge, it can be a washing machine. All of them, the general architecture of the chip inside is exactly same as this. Okay? Everything might be there, and one particular addition is called ML hardware, which I will talk about. Okay, so why AI? What is AI? I don't think I need to introduce AI. Okay? AI is generally doing something that we thought programs can't do earlier. No, programs are doing such complex things. Before I finish typing a sentence, it is telling me what I'm thinking and what I'm going to write. Right? So, because it looks unusual, we're calling it AI. Okay? Intelligence, but it can do more than what we were doing earlier. And a subset of AI is called, that is, how does a machine learn? How can you train it to do what the magic it is doing? And one subset of machine learning is deep learning, which is extremely complex machine learning. Okay, so lots and lots of nodes which are built to create some complex circuit which does some really wonderful things. And Earth's energy is being spent. So this color means it is blue. We don't know. Unless somebody says this is blue, we don't know it is blue. Right? But once somebody has told us, somebody has shown us many examples in our childhood, what is blue and what is red, now it's imprinted in our brain. Whenever we see it, yeah, we know it is blue because we've been taught that way. Okay? And it's not easy to learn just by showing one example. We've been shown hundreds of examples. So many years we spend in trying to learn all of these things. Okay? So the same thing, machines can also learn, and that learning is called training. And you feed a lot of data to it. Once you have trained it, the machine is ready to do its work. And suddenly you are giving an object to it. You ask it what color it is, or what object it is, or I have typed three words, what do you think is the next 3 words? That is called inference. Okay? So inference is what happens when a trained machine is available for you and that is working for you. Okay? So training is very compute intensive, takes a lot of time and thousands of data to train. Inference is after everything is trained, a network becomes small and it is optimized for a particular task. And that's called inference. If you want to really look at it, okay, all of these algorithms are really networks. When you say network, you take some data, you multiply, add with some coefficients, and then you add that to a coefficient, multiply that with a coefficient, do some inversion of the matrix, all kinds of stuff. And finally you come to an output. What to add, what to multiply, with what factor to multiply, how much to add, how much to subtract, all those are initially unknowns. As you feed information to it, which is called a training data set. Okay, everybody talks about data set. I have a data set, so can I run ML algorithms on it? The data set is a bunch of data. Okay, some of it may be classified. That means that you know the data already says, I have this picture. This picture is a dog. I have this picture, it's a cat. I have this picture, it's a human. Like that, you have billions of pictures. That means they're already classified. Sometimes they're not classified also. You can figure out patterns in it even though it's not classified. So it's called a training data set. And you feed all of that to it, and then you feed hundreds, thousands of images. Each time you feed an image, you have thousands of nodes which are updated. Okay? So this takes a lot of processing. That's why NVIDIA is making so much money, because PCs can't do it. You need a heavy duty graphics processor. I'll talk about what that is also to do it. So it requires a lot of processing. Once you've done it, you have something called inference. And the inference, once you give the new data, it will tell you whether it's a cat or not. Or if you've trained it to distinguish both cat, dog, and an elephant, it will tell you it's a cat, dog, elephant, or none of the above. Okay, it will only do what it has been trained for. Suddenly out of the blue, it will not say it's a giraffe. Right? So inference is whatever it has been trained, now it can do. This process is much simpler than the process of training. Okay? So if you look at the methodology of the algorithm itself, the training is a feedback mechanism. You set some parameters or coefficients to your network result, and you get a feedback saying that no, this is not okay. I know it's a cat, but this network is telling me it's a dog, so there's an error somewhere. Go back and change all your coefficients. So it goes back and changes the coefficients. So the training is back and forth. Why we are calling it edge intelligence. You need to know that okay, they have fallen, so somebody can go and help them. How do you know that somebody has fallen? You have a device which is 3-axis accelerometer. Somebody has fallen. You have a device which is 3-axis accelerometer, like a measures acceleration. So when I want to find out particularly how acceleration works on a falling person, normally, like I told you, we are all facing 9.8 meters per second square. But when you suddenly fall, you are in a free fall. That means that gravity, okay, moves your body. So it's like weightless. People who are in space, or people who suddenly come from the building, they feel a bit of weightlessness. That's why all these heights. And then after you have fallen, create algorithms. So that's the AI, and that's why it is so popular today. Is that you don't have to think too much. You just have to feed a lot of data, and then the machine will figure out. Right? So, if you wanted to do this fall detection, you have a choice. Collect accelerometer. Machine has been learned, inference